So hello and welcome back to our regular session of machine learning training using Python. This is Atul from Edureka, and today our topic of discussion will be machine learning tutorial. So without delaying any further, let's drill down to today's agenda. So our very first topic of this session will be why machine learning, where I'll tell you how powerful the machine learning is and how various popular companies are implementing them. Next, we'll drill down to see what exactly machine learning is and how does it work. Now, once you understand how machine learning works in general, then we'll move ahead and see what are the various types of machine learning and discuss how each of them work and how we are using them knowingly or unknowingly in our day-to-day life. After we are done with the types of machine learning, I'll tell you what you can do with machine learning. Once you know its scope, you might get a common question like which algorithm should I use in a specific situation or things like that. So these things will be covered under this section. Finally, in the last part, we'll create 6 different machine learning models, compare them, and pick the best model and build the confidence such that the accuracy is most reliable. And yes, we'll be creating this using Python. I hope the agenda is clear to you guys. So why machine learning? To answer this, let's see why most popular companies are using machine learning. So starting with Netflix. Why Netflix is using machine learning? I'm sure every one of you have used Netflix or at least heard about it, right? So do you know when you visit Netflix, how do you get the list of movies which are very related to your interest? So how does Netflix does that? Netflix uses different algorithm that can predict and thus recommend the user for the new content based on their previous watch history. So the Netflix is using machine learning to generate a recommended list of movies for you. So for instance, say that I'm a Netflix user and have watched a series of movies like A, B, C, D, and E. So this is my history. Now when Netflix mines its data, thereby finding association rule, it finds that the movies A, B, and F have been watched along with movies F and G by millions of users. Fine. So there is an association rule that Netflix uses to recommend to its user, which just like me have watched movies A, B, and F. Suppose you have watched movie A, B, and F, so the Netflix will recommend movie G for you. Fine. Even the research suggests that more than 75% of what you are watching is being recommended by Netflix. Correct? Let's move ahead. So next is the Facebook tag. Facebook is using machine learning to tag in posts and images. It automatically recognizes the face in the image and gives suggestion for who is the person in the image. Machine identifying the person in the picture. Really cool, isn't it? The next comes one of the most trending and popular innovation from Amazon, the Alexa. So Alexa is Amazon's virtual personal assistant that has been around for about 2 years and it keeps on getting smarter. So Alexa is using a huge amount of machine learning starting from speech recognition to wake word detection for answering the question and even to the knowledge extraction and synthesis of spoken language. A lot of computation is happening within the AWS. So if you're a developer, you can get the Alexa developer kit to know more about it. Fine, rest of you can just go ahead and purchase it from Amazon. Okay. So the next and most common of them all is spam filtering. Do you know how your mail is getting classified and filtered as spam or not a spam mail? You know what? This is also done using the algorithms of machine learning. Fine. I guess by now all of you are excited to know what machine learning is. So without delaying any further, let me tell you what is machine learning. Well, machine learning is a subset of artificial intelligence which provides systems or machine the ability to learn automatically and improve from experience without being explicitly programmed. Machine learning enables the computer to act and make data-driven decisions rather than being explicitly programmed to carry out a certain task. Now, these programs are designed to learn and improve over time when exposed to new data. So every one of you got what is machine learning? Okay. So let's move ahead and see in general how a machine learning works. So one of the approaches is where the machine learning algorithm is trained using a labeled or unlabeled training dataset to produce a model. Now this new input data is introduced into the machine learning algorithm and it makes its prediction based on the model. The prediction is evaluated for accuracy, and if the accuracy is acceptable, the machine learning algorithm is deployed. And if the accuracy is not acceptable, the machine learning algorithm is trained again and again with an augmented training dataset. Fine. So this is just a very high level example as there are many other factors and steps which are involved in the working of a machine learning. Fine. So let's move on and subcategorize machine learning into three different types. First being the supervised learning, next unsupervised learning, and reinforcement learning. Let's see what each of them are, how they work, and how each of them is used in different fields. Don't worry, I'll make sure that I use enough implementation of all three of them to give you a proper understanding. So starting with supervised learning. So what it is? Let's see the mathematical definition of supervised learning. If you ask me, mathematically supervised learning is where you have an input variable x and an output variable y, and you use an algorithm to learn the mapping function from input to the output such that y equal fx. Now your goal is to approximate the mapping function so well that when you have a new input data x, so you can predict the output variable y for that data. Any question, anyone? Okay, Shubham has written that he didn't understood the concept of supervised learning. Okay, Shubham, let me simplify this. We can rephrase or understand the mathematical definition of supervised learning as the machine learning method where each instance of a training dataset is composed of input attributes and an expected output. The input attribute of a training dataset can be of any kind of data. It can be a pixel of image, a value of database row, or it can even be an audio frequency histogram. Right. So for each input instance, an expected output value is associated with it. This value can be a discrete representing a category or can be a real continuous value. In either case, the algorithm learns from the input pattern that generate the expected output. Now, once the algorithm is trained, it can be used to predict the correct output of a never seen input. Okay, Shubham, is it clear now? All right, cool. So let's move ahead. This image shows an example of supervised learning process used to produce a model which is capable of recognizing ducks in the image. The training dataset is composed of labeled picture of ducks and non-ducks. The result of supervised learning process is a predictive model which is capable of associating a labeled duck or not duck to a new image presented to the model. Now once it is trained, the resulting predictive model can be deployed to a production environment, a mobile app for example, in order to recognize the new pictures. Fine. Now you might be wondering why this category of machine learning is named as supervised learning. Well, it is called as supervised learning because the process of an algorithm learning from the training dataset can be thought of as a teacher supervising the learning process. We know the correct answer the algorithm iteratively makes while predicting on the training dataset and is corrected by the teacher. The learning stops when the algorithm achieves an acceptable level of performance. Fine. Now let's see some of the popular use cases of supervised learning. Starting with document classifier. The machine or the model is trained with training dataset. Once trained, the machine can easily classify and sort the documents based on some criteria. Fine. Next is the weather app. Based on some prior knowledge, like when it is sunny, the temperature is higher, or when it is cloudy, the humidity is higher, or etc. Something like that. So what the weather app is doing, that based on some prior knowledge, it is predicting the parameter for a given time. Another example is biometric attendance or biometric verification, where you train the machine or your model, and after a couple of input of your biometric identity, be it your thumb, iris, or earlobe, the machine can validate your future input and can easily identify you. Okay. So this was all about the supervised learning part. Now let's move ahead and learn about the next category of machine learning, the unsupervised part. So again, mathematically unsupervised learning is where you have an input data x, but there is no corresponding output variables associated to it. The goal of unsupervised learning is to model the underlying structure or distribution in the data in order to learn more about the data. So before you ask me, let me rephrase you this in a simple term. In unsupervised learning approach, the data instances of a training dataset do not have an expected output value associated to them. Instead, the unsupervised learning algorithm detects pattern based on some innate characteristics of the input data. An example of machine learning task that applies unsupervised learning is clustering. In this task, similar data instances are grouped together in order to identify clusters of the data. You can see from the image here, it shows an example of an unsupervised learning process. This algorithm processes an unlabeled training dataset, and based on some instances or characteristics, it groups the picture into 3 different clusters. But despite the ability of the algorithm to group similar data into different clusters, it cannot identify labels to the group. The algorithm only knows which data instances are similar, but it cannot identify the meaning of this group. Okay. Now again, you might be wondering why this category of machine learning is named as unsupervised learning. Okay. So these are called as unsupervised learning because unlike supervised learning, there is no correct answer and there is no teacher. Algorithms are left on their own to discover and present the interesting structure in the data. So let's see some of the example of unsupervised learning. Suppose your friend invites you to his party where you meet totally stranger. Now you classify them using the unsupervised learning, that is, you don't have any prior knowledge about them. And this classification can be done on the basis of gender, age group, dressing, educational qualification, or whatever way you might like. Hold on guys, we have a question from Sashank. Okay, how this learning is different from supervised learning? Well, Sashank, it's because you didn't have any prior or past knowledge about the people, you just kept on classifying them on the go. Suppose you met person A and said that he belongs to X category. Person B, he belongs to Y category. Person C, he belongs to X category. So what you're doing here, you are just classifying them on the go. You're meeting them and you're just classifying it. Okay. Is it clear now, Sashank? Okay, fine. So let's see another example. Suppose you have never seen a football match before and by chance you watch a video on internet. Now what you do, you can classify the players on the basis of different criterion like player wearing same sort of kits are in one class or player of one style are in one class, which includes the players, goalkeeper, referee, or even you can group the players on the basis of the playing style like he's an attacker or he's a defender or whatever way you observe thing, you can just classify it. Okay. So next is the popular recommendation system. Remember when you view products to purchase at Amazon, it automatically recommends some other items too along with it. So how does it do that? Well, it's also an application of unsupervised learning. The machine learns from the choice based on different user. That is, what is the most common product that a user is buying or viewing after purchasing or viewing the first product. Don't you think it's a really cool concept? Right. Well, I personally found this feature really amazing. So in the above example, what you're doing is you're just creating the cluster based on some random criteria. Well, even unsupervised learning uses the same concept. I assume by now you guys have a proper idea of what unsupervised learning means. If you have any slightest doubt, don't hesitate and add your doubt to the comment section. I'll be happy to answer them for you. Okay, let's discuss the third and the last type of the machine learning, that is reinforcement learning. So what is reinforcement learning? Reinforcement learning is a type of machine learning algorithm which allows the software agent and machine to automatically determine the ideal behavior within a specific context. To maximize its performance. All it does is it performs hit and trial method to learn. Fine. The reinforcement learning model is about the interaction between two elements, the environment and the learning agent. The learning agent leverages two mechanisms, namely exploration and exploitation. When the learning agent acts on trial and error basis, it is termed as exploration. And when it is based on the knowledge gained from the environment, it is termed as exploitation. Now the environment rewards the agent for correct action, which is the reinforcement signal. Leveraging the rewards obtained, the agent improves its environment knowledge to select the next action. So in this example, you can see that we have an agent which is confused to decide which among the two pictures is of a duck. So what it does, it observes the environment and performs some action using some policies. Now once the action is performed, the model gets a reward or penalty point for it. As you can see that the machine has chosen bunny as a duck, so it will get minus 50 point for the wrong answer. Okay. Now after it gets the penalty point, the machine realizes that what path it followed or what decision it made was completely wrong. Thereby it updates its policy accordingly, and after many iterations, its policy gets optimized where the machine gives all the results correctly. Now let's see an example of how Pavlov trained his dog using the reinforcement training. This should make things easier for you to understand. Okay, so what Pavlov did, he integrated the learning in 4 different stages. Initially, Pavlov gave meat to his dog, and in response to the meal, the salivation in dog got increased. In the next phase, what he did, he created a sound with a bell, but did not give him the food. So this time the dog did not respond anything. So in the third phase, what he did, he tried to condition his dog by ringing the bell and then giving him the food. Now seeing the food, the dog started salivating again. Eventually what happened, the dog started to salivate just after hearing the bell, even if the food was not given to him. Why did it happen? So it happened because the dog was reinforced that whenever the master will ring the bell, he's going to get the food. Okay. I hope the concept of reinforcement learning is completely clear to you. Okay. By now you have attained some understanding of what is machine learning and you are ready to move ahead. Now we have covered the basics of machine learning. I'm sure you might be wondering what you can do with machine learning. So let me connect you to the real life and tell you what all are the things which you can easily do using the concepts of machine learning. So you can easily get answer to the questions like which types of house lies in this segment, or what is the market value of this house, or is this a mail, a spam or not a spam? Is there any fraud? Well, these were some of the questions you could ask to the machine. But for getting an answer to these, you need some algorithm. The machine need to train on the basis of some algorithm. Okay, but how will you decide which algorithm to choose and when? Okay, so the best option for us is to explore them one by one. So the first is classification algorithm, where the category is predicted using the data. If you have some question like, is this person a male or a female? Or is this a male a spam or not a spam? Then these category of question would fall under the classification algorithm. Classification is a supervised learning approach in which the computer program learns from the input given to it and then uses this learning to classify new observation. Some examples of classification problems are speech recognition, handwriting recognition, biometric identification, document classification, etc. Shall we move ahead? Okay. So next is the anomaly detection algorithm, where you identify the unusual data point. So what is anomaly detection? Well, it's a technique that is used to identify unusual patterns that do not conform to expected behavior, or you can say the outliers. It has many applications in business, like intrusion detection, like identifying strange patterns in the network traffic that could signal a hack, or system health monitoring, that is spotting a deadly tumor in the MRI scan. Or you can even use it for fraud detection in credit card transaction, or to deal with fault detection in operating environment. So next comes the clustering algorithm. You can use this clustering algorithm to group the data based on some similar condition. Now you can get answer to which type of houses lies in this segment or what type of customer buys this product. The clustering is the task of dividing the population or data points into a number of groups such that the data point in the same groups are more similar to other data points in the same group than those in the other groups. In simple words, the aim is to segregate groups with similar trait and assign them into cluster. Now this clustering is a task of dividing the population or data points into a number of groups such that the data points in the X group is more similar to the other data points in the same group rather than those in the other group. In other words, the aim is to segregate the groups with similar traits and assign them into different clusters. Let's understand this with an example. Suppose you're the head of a rental store and you wish to understand the preference of your customer to scale up your business. So is it possible for you to look at the detail of each customer and design a unique business strategy for each of them? Definitely not, right? But what you can do is to cluster all your customer, say into 10 different groups based on their purchasing habit, and you can use a separate strategy for customers in each of these 10 different groups. And this is what we call clustering. Next, we have regression algorithm, where the data itself is predicted. Question you may ask to this type of model is like, what is the market value of this house? Or is it going to rain tomorrow or not? So regression is one of the most important and broadly used machine learning and statistics tool. It allows you to make prediction from data by learning the relationship between the features of your data and some observed continuous valued response. Regression is used in a massive number of applications. You know what? Stock prices prediction can be done using regression. Now you know about different machine learning algorithm. How will you decide which algorithm to choose and when? So let's cover this part using a demo. So in this demo part, what we'll do, we'll create 6 different machine learning model and pick the best model and build the confidence such that it has the most reliable accuracy. So for our demo part, we'll be using the iris dataset. This dataset is quite very famous and is considered one of the best small project to start with. You can consider this as a hello world dataset for machine learning. So this dataset consists of 150 observation of iris flower. There are 4 columns of measurement of flowers in centimeters, the 5th column being the species of the flower observed. All the observed flowers belong to one of the 3 species of Iris setosa, Iris virginica, and Iris versicolor. Well, this is a good project because it is so well to understand. The attributes are numeric, so you have to figure out how to load and handle the data. It is a classification problem, thereby allowing you to practice with perhaps an easier type of supervised learning algorithm. It has only 4 attributes and 150 rows, meaning it is very small and can easily fit into the memory. And even all of the numeric attributes are in the same unit and the same scale. It means you do not require any special scaling or transformation to get started with. So let's start coding, and as I told earlier, for the demo part, I'll be using Anaconda with Python 3.0 installed on it. So when you install Anaconda, how your navigator would look like. So this is my homepage of my Anaconda navigator. On this, I'll be using the Jupyter Notebook, which is a web-based interactive computing notebook environment, which will help me to write and execute my Python codes on it. So let's hit the launch button and execute our Jupyter Notebook. So as you can see that my Jupyter Notebook is starting on localhost 8890. Okay, so this is my Jupyter Notebook. What I'll do here, I'll select new notebook Python 3. This is my environment where I can write and execute all my Python codes on it. So let's start by checking the version of the libraries. In order to make this video short and more interactive and more informative, I've already written the set of code. So let me just copy and paste it down. I'll explain you then one by one. So let's start by checking the version of the Python libraries. Okay, so there's the code. Let's just copy it, and let's paste it. Okay, first let me summarize things for you. What we are doing here, we are just checking the version of the different libraries. Starting with Python, we'll first check what version of Python we are working on. Then we'll check what are the version of SciPy we are using. Then NumPy, Matplotlib, then Panda, then scikit-learn. Okay, so let's execute the run button and see what are the various versions of the libraries which we are using. Hit the run. So we are working on Python 3.6.4, SciPy 1.0, NumPy 1.14, Matplotlib 2.12, Pandas 0.22, and scikit-learn of version 0.19. Okay, so these are the version which I'm using. Ideally, your version should be more recent or it should match. But don't worry if you lag few versions behind, as the APIs do not change so quickly. Everything in this tutorial will very likely still work for you. Okay, but in case you are getting an error, stop and try to fix that error. In case you are unable to find the solution for the error, feel free to reach out Edureka even after this class. Let me tell you this, if you're not able to run the script properly, you will not be able to complete this tutorial. Okay, so whenever you get a doubt, reach out to Edureka and just resolve it. Now if everything is working smoothly, then now it's the time to load the dataset. So as I said, I'll be using the iris flower dataset for this tutorial. But before loading the dataset, let's import all the modules, function, and the object which we are going to use in this tutorial. Same, I've already written the set of code, so let's just copy and paste them. Let's load all the libraries. So these are the various libraries which we'll be using in our tutorial. So everything should work fine without an error. If you get an error, just stop. You need to work on your SciPy environment before you continue any further. So I guess everything should work fine. Let's hit the run button and see. Okay, it worked. So let's now move ahead and load the data. We can load the data direct from the UCI machine learning repository. First of all, let me tell you, we are using Panda to load the data. Okay, so let's say my URL is this. So this is my URL for the UCI machine learning repository from where I'll be downloading the data set. Okay. Now what I'll do, I'll specify the name of each column when loading the data. This will help me later to explore the data. Okay. So I'll just copy and paste it down. Okay. So I'm defining a variable names which consist of various parameters including sepal length, sepal width, petal width, and class. So these are just the name of column from the data set. Okay. Now let's define the data set. So dataset equals panda.read_csv. Inside that, we are defining URL and the names that is equal to name. As I already said, we'll be using Panda to load the data. All right. So we are using panda.read_csv. So we are reading the CSV file, and inside that, from where that CSV is coming, from the URL. Which URL? So this is my URL. Okay. Our names equal names. It's just specifying the names of that various columns in that particular CSV file. Okay. So let's move forward and execute it. So even our data set is loaded. In case you have some network issues, just go ahead and download the iris data file into your working directory and load it using the same method. But yeah, make sure that you change the URL to the local name or else you might get an error. Okay. Yeah, our data set is loaded. So let's move ahead and check our data set. Let's see how many columns or rows we have in our data set. Okay. So let's print the number of rows and columns in our data set. So our data set is dataset.shape. What this will do, it will just give you the numbers of total number of rows and total number of column, or you can say the total number of instances or attributes in your data set. Fine. So print dataset.shape. What you are getting? 150 and 5. So 150 is the total number of rows in your dataset and 5 is the total number of columns. Fine. So moving on ahead, what if I want to see the sample dataset? Okay. So let me just print the first 30 instances of the dataset. Okay. So print dataset.head. What I want is the first 30 instances. Fine. This will give me the first 30 result of my data set. Okay. So when I hit the run button, what I'm getting is the first 30 result. Okay. 0 to 29. So this is how my sample data set looks like. Sepal length, sepal width, petal width, and the class. Okay. So this is how our data set looks like. Now let's move on and look at the summary of each attribute. What if I want to find out the count, mean, the minimum and the maximum values and some other percentiles as well? So what should I do then? For that, print dataset.describe. What it will give, let's see. So you can see that all the numbers are the same scales of similar range between 0 to 8 centimeters, right? The mean value, the standard deviation, the minimum value, the 25 percentile, 50 percentile, 75 percentile, the maximum value, all these values lies in the range between 0 to 8 centimeter. Okay. So what we just did is we just took a summary of each attribute. Now let's look at the number of instances that belong to each class. So for that, what we'll do, print dataset first of all. So let's print dataset and I want to group it, group by using class, and I want the size of it, size of each class. Fine. And let's hit the run. Okay, so what I want to do, I want to print what? Dataset. How I want to get it? I want it by class. So group by class. Okay, now I want the size of each class. Find the size of each class. So group by class dot size. Execute the run. So you can see that I have 50 instances of iris setosa, 50 instances of iris versicolor, and 50 instances of iris virginica. Okay, all are of data type integer of base 64. Fine. So now we have a basic idea of our data. Now let's move ahead and create some visualization for it. So for this, we are going to create two different types of plot. First would be the univariate plot and the next would be the multivariate plot. So we'll be creating univariate plots to better understand about each attribute. And the next we'll be creating the multivariate plot to better understand the relationship between different attributes. Okay, so we start with some univariate plot, that is plot of each individual variable. So given that the input variables are numeric, we can create box and whiskers plot for it. Okay, so let's move ahead and create a box and whiskers plot. So dataset.plot, what kind I want? It's a box. Okay, and do I need a subplot? Yeah, I need subplots for that. So subplots equal true. What type of layout do I want? So my layout structure is 2 cross 2. Next, do I want to share my coordinates, x and y coordinates? No, I don't want to share it. So share x equal false, and even share y, that too equals false. Okay, so we have here dataset.plot kind equal box. My subplots is true, layout 2 cross 2, and then what I want to do it, I want to see it. So plot dot show, whatever I created, show it. Okay, execute it. Now this gives us a much clearer idea about the distribution of the input attribute. Now what if I had given the layout to 2 cross 2? Instead of that, I would have given it 4 cross 4. So what it will result, just see. Fine, everything would be printed in just one single row. Hold on guys, Arya has a doubt. He's asking that why we are using the share x and share y values. What are these? Why we have assigned false values to it? Okay Arya, so in order to resolve this query, I need to show you what will happen if I give true values to them. Okay, so be with me. So share x equal true and share y that equals true. So let's see what result we'll get. You're getting it. The x and y coordinates are just shared among all the 4 visualization, right? So Arya, you can see that the sepal length and sepal width has y values ranging from 0.0 to 7.5, which are being shared among both the visualization. So is with the petal length, it has a shared value between 0.0 to 7.5. Okay, so that is why I don't want to share the value of x and y. So it's just giving us a cluttered visualization. So Arya, why I'm doing this? I'm just doing it because I don't want my x and y coordinates to be shared among any visualization. Okay, that is why my share x and share y value are false. Okay, let's execute it. So this is a pretty much clear visualization, which gives a clear idea about the distribution of the input attributes. Now, if you want, you can also create a histogram of each input variable to get a clear idea of the distribution. So let's create a histogram for it. So dataset.hist. Okay, I would need to see it. So plot.show. Let's see. So there's my histogram, and it seems that we have two input variables that have a Gaussian distribution. So this is useful to note as we can use the algorithms that can exploit this assumption. Okay, so next comes the multivariate plot. Now that we have created the univariate plot to understand about each attribute, let's move on and look at the multivariate plot and see the interaction between the different variables. So first, let's look at the scatter plot of all the attribute. This can be helpful to spot structured relationship between input variables. Okay, so let's create a scatter matrix. So for creating a scatter plot, we need scatter matrix, and we need to pass our data set into it. Okay, and then what I want to see it. So plot.show. So this is how my scatter matrix looks like. It's like that the diagonal grouping of some pair, right? So this suggests a high correlation and a predictable relationship. All right, this was our multivariate plot. Now let's move on and evaluate some algorithm. Now it's time to create some model of the data and estimate their accuracy on the basis of unseen data. Okay, so now we know all about our data set, right? We know how many instances and attributes are there in our data set. We know the summary of each attribute. Now I guess we have seen much about our data set. Now let's move on and create some algorithm and estimate their accuracy based on the unseen data. Okay, now what we'll do, we'll create some model of the data and estimate their accuracy based on some unseen data. Okay, so for that, first of all, let's create a validation data set. What is a validation data set? Validation data set is your training data set that will be using it to train our model. Fine. All right, so how we'll create a validation data set? For creating a validation data set, what we are going to do is we are going to split our data set into two parts. Okay, so the very first thing we'll do is to create a validation data set. So why do we even need a validation data set? So we need a validation data set to know that the model we created is any good. Later, what we'll do, we'll use the statistical method to estimate the accuracy of the model that we create on the unseen data. We also want a more concrete estimate of the accuracy of the best model on unseen data by evaluating it on the actual unseen data. Okay, confused? Let me simplify this for you. What we'll do, we'll split the loaded data into two parts. The first 80% of the data we'll use it to train our model, and the rest 20% will hold back as the validation data set that will use it to verify our trained model. Okay, fine. So let's define an array. This is my array. What it will consist of? It will consist of all the values from the dataset. So dataset dot values. Okay. Next, I'll define a variable x, which will consist of all the column from the array from 0 to 4, starting from 0 to 4. And the next variable y, which would consist of the array starting from this. So first of all, we'll define a variable x that will consist of the values in the array starting from the beginning 0 till 4. Okay, so these are the column which will include in the x variable. And for a y variable, I'll define it as a class or the output. So what I just need the fourth column, that is my class column. So I'll start it from the beginning and I just want the fourth column. Okay, now I'll define my validation size, validation underscore size. I'll define it as 0.20 and I'll use a seed. I'll define seed equals 6. So this method seed sets the integer starting value used in generating random number. Okay, I'll define the value of seed equals 6. I'll tell you what is the importance of it later on. Okay, so let me define first few variables such as x underscore train test, y underscore train, and y underscore test. Okay, so what we want to do is select some model. Okay, so model underscore selection. But before doing that, what we have to do is split our training data set into two halves. Okay, so dot train underscore test underscore split. What we want to split is the value of x and y. Okay, and my test size is equals to validation size, which is 0.20. Correct. And my random state is equal to seed. So what the seed is doing here, it's helping me to keep the same randomness in the training and testing data set. Fine. So let's execute it and see what is our result. It's executed. Next, we'll create a test harness. For this, we'll use 10-fold cross validation to estimate the accuracy. So what it will do, it will split our data set into 10 parts. Train on the 9 part and test on the 1 part. And this will repeat for all combination of train and test splits. Okay. So for that, let's define again my seed, that was 6 already defined, and scoring equals accuracy. Fine. So we are using the metric of accuracy to evaluate the model. So what is this? This is a ratio of number of correctly predicted instances divided by the total number of instances in the data set multiplied by 100, giving a percentage. Example, it's 98% accurate or 99% accurate, things like that. Okay. So we'll be using this scoring variable when we run the build and evaluate each model in the next step. So our next part is building model. Till now, we don't know which algorithm would be good for this problem or what configuration to use. So let's begin with 6 different algorithms. I'll be using logistic regression, linear discriminant analysis, k-nearest neighbor, classification and regression trees, neighbors, and support vector machine. Well, these algorithms which I'm using is a good mixture of simple linear or non-linear algorithms. In simple linears, which included the logistic regression and the linear discriminant analysis, or the non-linear part, which included the KNN algorithm, the CART algorithm, the neighbors, and the support vector machines. Okay, so we reset the random number seed before each run to ensure that evaluation of each algorithm is performed using exactly the same data splits. It ensures the results are directly comparable. Okay, so let me just copy and paste it. Okay. So what we are doing here, we are building 5 different types of model. We are building logistic regression, linear discriminant analysis, k-nearest neighbor, decision tree, Gaussian neighbors, and the support vector machine. Okay. Next, what we'll do, we'll evaluate model in each turn. Okay. So what is this? So we have 6 different model and accuracy estimation for each one of them. Now we need to compare the model to each other and select the most accurate of them all. So running this script, we saw the following result. So we can see some of the result on the screen. What is this? It is just the accuracy scored using different set of algorithms. Okay, when we are using logistic regression, what is the accuracy rate? When we are using linear discriminant algorithm, what is the accuracy, and so and so. Okay, so from the output, it seems that LDA algorithm was the most accurate model that we tested. Now we want to get an idea of the accuracy of the model on our validation set or the testing data set. So this will give us an independent final check on the accuracy of the best model. It is always valuable to keep a testing data set for just in case you made a overfitting to the testing data set or you made a data leak. Both will result in an overly optimistic result. Okay. You can run the LDA model directly on the validation set and summarize the result as a final score, a confusion matrix, and a classification report. Okay. Thank you guys. This was all for this session. In case you have any doubt or queries, feel free to add your query on the chat box, or even after the class, you can reach out to Edureka support team and we'll help you to resolve your query. Thank you.